Welcome all to our third MQ session. We have Matt here waiting to talk on REST APIs and MQ. So without further ado, I shall hand over to him.
Thank you. So, hi everyone, good afternoon. My name's Matt Lemming, and I'm the architect for MQ on ZOS. I work at Hursley, or normally I work at Hursley. Obviously, at the moment I'm working in near the Great Wall of China at my house. But normally I'm at Hursley and working on the MQ side of things. And I've been at Hursley for the last 18 years, and at least 10 of those recent years have been looking at the MQ and the MQ on ZOS side of things. And the reason I'm giving this particular presentation is I've been involved quite a lot with MQ's growing REST API support. So that's kind of why I'm talking about this to you today. So in terms of what I wanted to talk about, I'm going to kind of have a little bit of a preamble talking about why REST is important. And I suspect many of you are aware of this already. And I'm going to talk about why MQ is useful and what does that mean. Again, I suspect many of you are aware of that. And then I'm going to start looking at what happens when these two worlds collide, REST and MQ. What does that mean? And really, there's two parts to that. The first part is the MQ messaging REST API. And I'm going to spend, about half of the presentation talking about our new messaging REST API. And then I'm going to kind of shift gears a little bit and start talking about ZOS Connect Enterprise Edition, which is another way of exposing REST APIs. And in particular, I'm going to talk about how it can be used to expose MQ queues via a REST API. Okay? And I'm going to kind of compare and contrast the messaging REST API that's in MQ versus the RESTful support for MQ in ZOS Connect Enterprise Edition. So there's a little bit of a disclaimer right at the front. There is another way of thinking about REST and doing REST with MQ, and that is App Connect Enterprise. And I'm not really going to cover that in this presentation, but I think it's fair to say that App Connect Enterprise is a very powerful way of exposing REST APIs and then kind of doing larger chunks of business logic that you can run from inside REST. Sorry, from inside App Connect Enterprise, but I'm not going to cover that here. So I'm going to look a bit closer at MQ and not go into the ACE side of things. Now, as I go through, if you've got any questions, then just stick them in the Zoom group chat, and I'll do my best to answer them. So ask questions as we go along, and I'll answer them as we go rather than leaving them all to the end, because I think it's easier to lose context if we leave them to the end. So starting off, why is REST? Why REST? Why is REST important? So a very brief bit of history. So REST has been around since 2000. It was a term coined by a man called Roy Fielding, who was really very fundamental to the development of the various W3 RFAs that built up the standards that make the web, and REST stands for representational state transfer. And it's actually quite a simple idea when you think of what REST actually gives you. It basically exposes objects via URLs, and then it defines operations on those objects by making use of the HTTP verbs. And in particular, REST is very good at doing CRUD-like operations. So if you want to create something, that's an HTTP post. If you want to read something, that's an HTTP get. And then that goes all the way down to deleting things as well. But it's fundamentally a very simple idea from a way of calling things. You have a URL, represents the object. HTTP verbs represent what you want to do to the object. And then the actual state that gets transferred comes in the HTTP body, whether that's the body of the HTTP request or the body of the HTTP response. So, part of the value of REST is it's really, really simple, or the basics are really simple, and then you can build those up in quite complicated ways, but the basics are really simple. Another significant piece of value from REST is the fact that it's basically just a way of sending data over the network, and that means you can kind of pretty much do that from any environment ever. Almost every programming language available today allows support for HTTP access, and that means that if you've exposed a REST API to your application, you can pretty much call that REST API from anywhere. And even in those places where maybe it's a little bit hard to reach REST APIs, there's often toolkits that can be used to kind of plug that gap. So, basically at the end of the day, if you've exposed a REST API, that can be driven pretty much from anywhere, assuming they're suitably authorized. And these two things, the fact that REST is available from anywhere and it's conceptually very simple, does mean that it's a really good way of exposing access to your systems and makes it easy for you to monetize your existing systems. But at the end of the day, because REST is basically HTTP, it does mean that those interactions tend to be very synchronous focused. So, if you want to submit a request, you send an HTTP request, that gets processed and you get a response back. So it's a very synchronous style of interacting with things, but very, very simple. So moving on to MQ. So MQ is basically an IBM product for asynchronous messaging. It's been around for 25 years or so, more like 27 years now. So it's actually been around longer than the idea of REST, and it provides asynchronous decoupled communications between applications. And so what that means is when applications want to communicate with each other, they don't communicate directly. Instead, they go indirectly via something called a queue, which is basically a place where the applications exchange data. And a set of these queues are managed by a queue manager, which is basically a process that sits there and is responsible for managing the state on queues. And you can, because it's this single man in the middle entity, you spend a lot of time making sure that that's highly available and resilient, and the applications can connect into it when they need to. And the benefit of messaging is there's several sets of benefits. The first thing is your applications don't need to be available at the same time. The fact that there's a highly available, resilient queue manager in the middle means they can talk to that and exchange data via that. But if the individual applications are temporarily down, that doesn't matter because the queue manager is almost always up. So in addition to having that benefit of availability, another benefit of asynchronous messaging is the fact that it provides a nice shock absorber. Because if you consider the fact that, sometimes some applications go faster than others, if a sending application is going faster than the application processing the requests from that sending application, MQ can sit in the middle and build up a set of messages on its queues and basically buffer those requests. So that your applications aren't directly coupled, and if there is a temporary slowdown on the back-end processing application, that doesn't result in immediate problems for the application sending in requests. And if you want to scale up that back-end application, it's typically just a question of having another instance of the application connected to the same queue, and these multiple back-end instances of the application sit there processing requests in a shared manner. So scaling up your back-end application and scaling it down is typically as simple as creating more instances of the application and pointing at the same set of queues. Now, as well as all of these kind of more basic capabilities, MQ provides a whole load of extra advanced technology on top of that. So we provide support for transactions, which basically allows you to group multiple sets of messages as a single sort of atomic unit. So you might say, I want to either send these 3 messages or send none of them at all, and transactions allow you to do that. We've got built-in support for transparent message encryption, where you basically, if your message data, you want to protect it so that nothing can go and look at it regardless of where it is, or no one unauthorized can go and look at it regardless of where it is, then that's just something you switch on in the queue manager and your messages are automatically protected. And then of course, MQ has a wide selection of options for making use of high availability and disaster recovery. And in particular, on ZOS, we've got queue sharing groups, which gives you a very, very high level of resilience. So, that was me waffling. Perhaps it'd be useful to have a bit of a comparison between MQ and REST APIs. Now, one thing I should point out before I go down this list is that MQ is a very concrete product. REST APIs are kind of a bit more of a generic concept. Okay, so I'm kind of presenting a concrete product here versus a generic concept. So the individual things that might expose a REST API might have slightly different answers to what I'm talking about here. But if we look at MQ, it has a very simple but powerful API, and that API, the MQI, is available on a variety of different programming languages and a variety of supported platforms. But at the end of the day, it's nowhere near as ubiquitous as a REST API. Okay, REST APIs can pretty much be called from any programming language or any platform, or probably the ones you really care about anyway. Okay, so REST APIs normally win in terms of availability of something you can actually call in the first place. MQ is pretty good. REST APIs are ubiquitous. MQ is a very asynchronous beast. So, you know, you don't have, like I said on the previous slide, when you're communicating via MQ, your applications don't have to be available at the same time. And because you've got this disconnect, it allows you to actually build up quite a rich set of interaction patterns. You've got request response, which might be truly asynchronous or perhaps pseudo-synchronous, where you issue a request and you wait for a response and you're sitting there waiting, or you might actually have properly asynchronous request response where you go and do something else before getting your reply. You have support for sending a message into MQ and not caring where it gets to, you know, fire and forget messaging. And then of course there's pub sub, which is a one-to-many interaction pattern. REST is quite different. Fundamentally, it is entirely synchronous, but from that synchronous basis, you can then go and build up a wide variety of interaction patterns. But that comes down to the actual, you know, the API that the back-end application exposing that API provides. So, you know, fundamentally, it's synchronous request response, but it could build up to more complex patterns. Scalability with MQ comes in two parts. Typically, you have a choice of either scaling the back-end service providing application by starting up more instances of that application against a single queue manager. And then there becomes a point where actually that single queue manager becomes a bottleneck, in which case you kind of then start to shard out messaging amongst a set of queue managers, and you can do that via queue sharing groups or MQ clusters. And there's a whole load of technology built into MQ and its clients that actually provide that capability. From a REST perspective, scaling's quite different. It's actually in a way simpler. You basically stick an IP sprayer in between your requesters and the actual thing that provides the REST API, and that sprays the work across the available set of backends. So they've got quite different approaches to scaling. As I mentioned earlier, MQ is a transactional beast. That means it allows you to group a set of messages together, perhaps 2, 3, or maybe thousands of messages together as a single atomic unit of work. And those things either happen together or they don't. And that's a very easy thing to do with MQ. And underpinning that as well, or related to it, is the fact that with MQ, when you send a message, it can be persistent, which means that that data, that request, will survive a queue manager shutdown and restart and can be processed at a later point. REST APIs aren't really transactional. Every single HTTP operation, every single REST operation should really be decoupled from the operations that are going around it. So even though you may issue a number of HTTP requests one after the other, they shouldn't have, well, they're not grouped together in any way that allows you to say, well, those first two worked fine, the last one failed. I'd like you to undo those first two ones that worked, please. That's not something that REST provides. That requires your applications and your clients to work together, and that actually can be quite a complicated thing. So from a reliability perspective, if you want to have grouped requests, MQ kind of solves that much better than REST does. Certainly it's at a high level, generic level. Now, it may be possible to solve it in individual examples, but that's something that REST API would have to worry about doing, whereas MQ does it for you. And then from an encryption perspective, both MQ and REST allow you to encrypt network protocols with your network data with TLS. You know, that's kind of easy to do, but MQ kind of goes a level on top of that, where you can actually go and encrypt your data you're sending throughout its entire lifetime, from the point it's sent into your network to the point when it's consumed, and that can be done without changing your applications. If you wanted to do that with a REST API, that would require a collaboration between the REST client and then the service exposing the REST API as well. So, it's quite hard to describe from a generic perspective, but it's doable, but it would require application and REST API work to do that. With MQ, it's kind of available out of the box, as it were. So a common question we get with MQ is, when do I use MQ versus a REST API? And that requires you to look very detailed level at what you're trying to do with your REST API. So I'm going to give a simple example here, but this is just a simple example. Okay, it's almost kind of a trivial example, because it's quite hard to go into a specific example without some real details, which we don't have time for. So as a high level, if you were, say, wanting to update someone's patient record for treatment and medicine they've received, or perhaps their billing information, that might be something you do with MQ, because you want to make sure that update happens eventually. And so that means support for transactions, because you can guarantee that update does happen, and it's tied with perhaps another update to a database or other interactions with MQ. Then that transactional capability and the resilience of MQ is a really perfect use case for interacting with critical customer data. Now, if you wanted to expose a product catalog out to a wider set of audience as possible, so they can actually go and access your catalog, query it, and see what's available, so they can potentially go and buy it, REST APIs are a perfect example here, because for starters, anyone can access your REST API because it is so ubiquitous. And also the fact that we're doing a read-only query of your catalog means that if there is any issue with an individual request, it doesn't matter, because it's a read-only request. If there's a failure, you just reissue that request. So this is a trivial example of when you might use MQ over REST APIs, but it sort of illustrates some of the considerations, but it does require you to, doing this for a concrete example does require you to kind of think about the individual things I mentioned on the previous slide. So this set of slides has really looked at what's a REST API and what's MQ, and how are they similar and how are they different. But actually, what I now want to look at is actually what happens if you get MQ and you start exposing that as a REST API. What does that mean? And so I'm going to spend, perhaps the next 20 minutes talking about that. So if anyone does have any questions, just feel free to put them in the chat. So what we've done over the recent couple of MQ releases is starting to expose MQ with more web capabilities. Okay. So now, if you were to get hold of an MQ910 or an MQ920 installation, then we've got a variety of different HTTP web-enabled capabilities available. And there's basically three pieces. We have a new web user interface for administering and monitoring, to some degree, your queue managers, and that's called the MQ console. And that's kind of a bit like MQ Explorer, but exposed via your web browser. So it's much easier to access. You don't need to install something local. You just connect in directly via your Firefox or Chrome or whatever. To partner that, we've also added a pair of REST APIs. One is a way of administratively interacting with your queue manager, so giving you the ability to do MQSC commands over HTTP. So that's a very powerful way of administering MQ, but without getting stuck using things like PCF, which is much more complex. And then we've also got this messaging REST API, which is a way of doing point-to-point messaging and an amount of pub-sub messaging, but without using our more traditional interfaces, so JMS and the MQI. And all of these three capabilities are exposed via a web server, which we've called the MQ web server, and that's basically an embedded WebSphere Liberty profile server that kind of gets shipped as part of MQ. So it's provided for free, it's part of the MQ product. When you install MQ910 or MQ92, you've got an optional bit you can install, which is the web server. You lay that down on disk, you configure it, you start it up, and you've suddenly got access to these REST APIs and the console, and you can decide which bits you want to make use of. and secure them and all that good stuff. And I'm going to talk about, some of those pieces from a messaging REST API, and that's where I'm going to focus now. So the messaging REST API is a relatively new thing. So we first produced part of it in 9.04, which is, I guess that's about 3 or so years ago now. And then since that point, we kind of put the first bit of the REST API for messaging out. We've gradually, incrementally improved it. And there's been quite a number of updates over the years. I should say that we did used to have an earlier version of a REST API, which was called the HTTP bridge. But that, if you wanted to use it, you had to take it and basically install it in your own web server. So it was provided with MQ, but required more effort to set up. The new REST API and the console and the administrative REST API are built into the product. Okay, so you install the product, you configure the web server, you start it up, and you're ready to go. You don't have to go and source an extra web server. So it's kind of much easier to get up and running with. And I really should make it clear that the REST API is something you don't have to have. If you want to make use of it, switch it on, enable it. If you don't want it, don't switch it on. Okay, so it's not something you're forced into. It's there if you need it, but you don't have to have it. And also, as you see, it's evolved over the last 3 years. It will continue to evolve. We're not done with it yet. There's a number of things we'd like to use to do to enhance it, and they will come over time, over the various CD releases. So let's start talking about the REST API and what it actually looks like. So we'll start off with kind of one of the most important functions of MQ, sending a message. Okay, so if you want to use the REST API to send a message to MQ, then it's actually really, really simple to do. So on the right hand side, you can see an example of what that the act of sending a message via the messaging REST API would look like, and I've kind of modeled it here on curl. Okay, so the first thing is, as I said, every REST API consists of a URL that represents the object you want to interact with. So in our case, we're talking about accessing a particular queue, Q1 in this case, on a particular queue manager, queue manager 1, QM1. And you can see that basically those 2 bits, the queue manager name and the queue name, slot into the URL. And what we're now trying to do, because we're talking about sending a message, that is the act of creating a message on that queue. So the URL has the word message in it, and because we're creating something, a message, then that uses the HTTP post verb. So it's a very natural way. This is basically following the REST interaction pattern perfectly. The URL represents where you're creating things, and the post represents the fact you're actually doing a creation. And so this, if you want to send a message to MQ, then you basically issue that post and you provide payload as part of the HTTP request body. And at the moment, we only support text-based payload. So you can send JSON, you can send free format text, or you can send XML data, for example. And that results in a MQ string formatted message residing on the queue. Now, as a result of sending that message, you might want to set another couple of MQMD parameters. You might want to say whether it's persistent or not. So that's done via header parameter. So there's this -h MQMD persistence parameter that kind of affects whether it's a persistent or non-persistent message or not. You can set expiry, and you can set correlation time as well. So you've kind of got the ability to do some fairly simple interactions with that message, but at the end of the day, it's kind of a very simple way of sending a message via REST. So it doesn't have the full power of the MQI, but then that's kind of not really what you're looking for with a REST API. You're looking for an easy way of getting your data into MQ from pretty much any point, which is why you're looking at REST in the first place. And like I say, at the moment it's text only. We have had a lot of requests to extend that to general binary payloads, and at some point that will come. So obviously, if you're sending a message to a queue, there's an equivalent operation of publishing a message to a topic. Now, this is pretty much the same as the REST API for a queue. The only difference is that because we're dealing with a topic, the URL that you interact with is slightly different. So we've still got the queue manager name, but you also have the topic string in here as well. So here I want to send a message to the red/blue/green topic, and basically that topic string goes in into the URL. Okay, and other than that, this API is pretty much the same as the queue one. Okay, it's a very simple way of publishing a message to a topic. Very simple. So in terms of receiving a message, again, if you want to receive a message from a queue, it's nice and simple. From a REST perspective, we've already defined kind of what the messages on the queue look like. They consist of this URL where you have a queue manager name and a queue name, and then it's got the word message at the end of it. So if you want to go and destructively get a message, destructively receive a message, then from a REST API perspective, that's done via an HTTP delete. Okay, and that, if you just issue that single call, delete, and that URL, then you'll get the first message on the queue. Now, obviously with MQ, you've always had the ability to go and query for other messages by providing a particular correlation ID. Perhaps you're waiting for a particular response with a particular correlation ID. So that request is provided as a query parameter, and you can see it here, question mark, correlation ID, and then a hex correlation ID. Or perhaps you're waiting for a message, but there's no actual message available on the queue yet. So you can issue an HTTP request for that and say, I'm going to wait for 60 seconds for that message that I want to turn up. And you can see that's done via another query parameter, which is this ampersand wait equals 60,000 milliseconds. So it's a very simple way of getting messages via REST. And if a message turns up and matches your query parameter, then that kind of comes back as the HTTP response. And there's two parts to that HTTP response. The first part is the headers, which kind of effectively are pieces of the MQMD. So whether there's a reply to queue associated with that message, what persistence was it, and then its correlation and message IDs. And then there's the response body itself, which, as I said before, has to be text at the moment. So it needs to be an XML format or a JSON format or something similar. And if you try and get a message that isn't text, then basically you'll get an error out of the REST API, and that message will get rolled back onto the queue. So, you know, it's a nice, simple way of exposing a getting API. Again, it's not got the full power of the MQI and the JMS APIs, but it is a simple, lightweight API. So I see I've had a question from Grant, which is there a ZOS version of the MQ web server? Yes, there is, Grant. Basically, the MQ web server is available on all supported MQ platforms from 9.10 and 9.20 LTS. So you can do it on ZOS, you can do it on IBM I, you can do it on distributed. And what I'm talking about here, you know, the content I'm discussing here is the same regardless of platform. The APIs are the same. Okay. Some of the administration of the web server becomes subtly different, and I'll talk about that briefly in a minute. But you know, basically the same capabilities are available everywhere. Thank you for the question. So moving on, there's a couple of other bits to the API, and then we're kind of done with the API, and I'm going to start talking about the administration at a high level. So far we've done sending a message to a queue, publishing a message to a topic, getting a message from a queue destructively, and you'll notice we haven't got a destructive way of subscribing to a topic and getting a message from that. Okay, so that currently is not part of the messaging REST API. That's something that a number of customers have asked for. We might add it at some point, but there is a way around that. You can use an administrative subscription and point that to a queue, and then you've got access via that to that via the existing queue-based REST API. So we do publish with the REST API. We don't yet do subscribe. So I just want to bring that point up while I remember. So the last couple of bits are actually browsing messages. So we talked about destructively getting a message. What about if you want to go and look at the messages on the queue, but you don't want to destructively get them? So we have a couple of pieces to this REST API. At its simplest, this is basically looks very much like the destructive getting REST API. It's just that you're doing a browse, you're doing effectively a display of the queue state, and that's done via an HTTP get as opposed to an HTTP delete. And other than that, the API kind of looks the same. So you can do a get via a particular correlation ID, and that will go and find that, if you don't provide a correlation ID, then you'll find the first message on the queue, or if you provide the correlation ID, it will go and find that particular instance of the message, and then it will return the message headers or the MQMD back to you as HTTP headers. And again, you've got the reply to queue, the persistence, the correlation, and message ID, and then the response body comes back as the MQM, the message body comes back as the HTTP response body. One thing I'd say you can't do with this is you can't wait for a message to turn up. You can't do a browse with wait with the messaging REST API. We haven't added support for that. If it's important to you, then do let us know. But there is another part to the browse API. So this one looks at an individual message. What we've also done is the ability to go and give a high-level list of the available set of messages on the queue. So this kind of looks similar to the individual browse API. The only real difference is the URL, because we're saying actually, we're looking at a list of messages, so the end of the URL changes to be message list rather than message. And when you issue a get to this, it will return you a list of the available messages on the queue, but only a subset of the information. Basically, it returns you their correlation ID, message ID, and what format they are. And the idea here is you can use this information to quickly walk down the queue, the known state of the queue at the point when you did this list of the queue, and then you can go and individually browse those messages, or perhaps destructively get those messages. And the value here is it kind of gives you a concrete view of the queue at one particular point in time, and then you can walk through that snapshot in time. Now, it may be that the messages have been destructively got during that time, in which case you won't be able to get them, but it's kind of a trade-off. The idea here is that it gives you a snapshot in time. You can walk down that, and that's really the aim for this API. So just bearing that in mind, and the idea here is that you kind of use this in conjunction with the previous browsing API to build up whatever your interaction pattern is. But of course, because MQ is kind of, the state of a queue can change over time, especially if you've got multiple applications interacting with it. You have to bear in mind that if you go and browse a message once, it might not be there if you try and browse it again, or if you go and destructively get it again. So it's just worth bearing that in mind. That's kind of why this API is shaped like it is. So that's kind of what the API looks like. As you can see, it's quite simple, but it does allow you to do quite a lot of messaging capabilities. And as I said, it's ubiquitous. So really, all of that API can be driven from anywhere. You can run that from an app running on your phone. You can drive it from Node.js. You can drive it from a web browser. You can run it on the command line using curl. You can run it from anywhere. And now that we've talked about the API, what does that mean in terms of the individual messages that the API generates or it consumes? So the key thing here is, if you're sending a message via the messaging REST API, that is like any other MQ message, okay? At the end of the day, the MQ messaging REST API is a JMS application running inside our web server, and it will send a JMS message as a result of your application issuing an HTTP post request. So any backend application that can process a JMS message can be interacted with. So you can have REST API messages driving an existing JMS application. You can have REST APIs interacting with other REST API based applications, or you can have REST APIs applications driving the REST API driving backend KICS transactions as well. So you can kind of mix and match how you do this, and that applies both whether you're using the sending message API or the receiving message API. It doesn't matter how you combine your APIs. You've got all of the flexibility of MQs there, and things like alias queues, shared queues, remote queues, clustering, all of those capabilities are available via the REST API. There's no restrictions on what you can do there. So once a message comes into MQ out of the REST API, it's basically just another MQ message. So here's what I want to come back to as quite a key point: transactional considerations. Okay, and I kind of touched on this right at the beginning. I want to go into it in a bit more detail now. MQ is a transactional thing. JMS, the MQI, they're highly transactional APIs, especially when running inside things like CICS or IMS or Web Server Application Server. HTTP is not transactional, and that means that the MQ REST API is not transactional. So if you want to go and consume a message via the MQ messaging REST API and then send that message someone onto another queue via the messaging REST API, then you can absolutely do those two things, but they're not transactionally grouped together. So they're ordered in time, but they're not transactionally tied together. So, if you experience a failure somewhere during that application flow, things may or may not be atomic, and it's quite hard to tell what's going on. So just bear that in mind. If you want transactions and transaction support, don't use the MQ REST API, use the MQI or JMS or something like that. If you want a lightweight, easy to use API for just doing messaging from an application that just wants to send messages into MQ or browse messages in MQ or consume data that's not high value, then the REST API is useful for that. So let's look at some details here. So here, I'm sending a message into MQ, okay? Sending to a particular queue via doing an HTTP post. Now, if I experience a network failure while that request is going on, so I do my post and the message is somewhere on the wire between the application and the queue manager, and there's a failure, it is really, really hard to understand where that failed. So in the top case, I've sent a message to MQ and that message didn't actually get to MQ before the network failed. From an application perspective, I'll get a HTTP failure, and I won't know if my message got sent or not. Okay, and probably what I'll do is try and resend it. If, however, I did actually successfully send that message, it's ended up in the queue. So I'm now talking about the bottom picture, and the network fails. I still don't know whether that message got to the queue or not. In this case, it did. If I tried to resend that message, I would get, two messages in the back end queue, and then that, then we're talking about that potentially being a problem. Is that a problem or not? Depends on what the back end application does. Is it idempotent or not? But it's very hard for you to tell the difference from an MQ perspective, especially if this post is tied up with the subsequent get, or something that happened prior to this point. Those two things aren't coupled. This will have happened. There will, the message will have ended up on the queue, or it won't have done. And there's not much you can do about it other than either try and reset and put complicated compensation logic in there to figure out if you sent it or not. So REST doesn't solve this problem for you. Nice transactions. A similar case, and perhaps possibly more of a nastier case, is what happens when I'm trying to consume a message. So here, it's interesting, my slides are just going a bit wonky. Right, there you go. So here I want to consume a message that's already on the queue, so I'm going to destructively get it. Now, if I issue my destructive get and the network glitch happens before I've consumed the message, that's fine. I can just go and request it again, okay? But I can't distinguish between this case, where I can go and get the message because I never really got it in the first place, or the scenario on the bottom, where actually I did get the message, it's been taken off the queue, but then there was a network glitch and the message was lost on the way back to me, right? I can't tell between those two scenarios with the MQ REST API or any other REST API when you're talking about destructively deleting data. And I might have lost something valuable here. If that message represented some important information about my bank account, that would be really, really bad. If that's just the response to a query that I sent, the fact that I've lost it doesn't matter or not, I can just reissue the query. So, be very, very careful about whether you decide to use MQ's REST API with valuable data. If that message was a persistent message, that implies it's got value. Therefore, using it via, a non-transactional API like the REST API is probably a bad idea. But if that's my response to a query about, what's the state of my catalog, then that's perfectly fine. So just bear in mind, you can lose data, and that's just the nature of HTTP requests, because there's nothing that you can use to transactionally guarantee you get the message, or you reliably get that message. And if something went wrong, you roll it back on the queue and you can get it again. You can lose data. So not for high valuable data, I would suggest in general REST APIs. So, these two slides are quite important, because if you don't think about them carefully when you're using a REST API, you might end up setting yourself up for a problem at some point. And of course, most of the time, this will just work fine. It's just when you have a transient glitch somewhere that maybe occurred once, maybe it's a one-off, but you could lose your valuable data if you hadn't thought about it up front. So security. So I'm going to cover this quite briefly. Okay, there's a lot of options when it comes to security with the REST API. The key thing is it is secure by default. When you start up the web server, which exposed is the REST API, it is HTTPS by default, and you have to add access to the REST API. So it doesn't expose everything by default. You kind of expose what you need as and when you need it. And there's kind of two parts to it. The first one is there's a user registry which defines which users have access to what. And there's a number of options for this, and they're all configured as part of the MQ web server. The simplest answer, if you just want to try something out, is actually you put the registry and the usernames and groups inside XML, and the web server manages that for you. If you want to then go and do things like interact with an existing LDAP repository that you might have running on distributed or on Z, then the web server supports access connecting into an LDAP repository to provide your user registry, and that's something that you can use on any environment. And of course, on ZOS, we've got support for going back into SAF. So if you've already got an existing set of MQ users who've got access to particular queues, then you can wire directly into those via SAF into RACF or whatever you've got. And that's kind of the natural one for use on ZOS. And then on top of that, there's a set of set of roles which define what level of access you've got. Now, from an MQ messaging REST API, the only real role that we expose is this user role, where basically your user ID gets checked against the backend registry, and you get whatever access that registry gives you in terms of queues and the ability to connect and what you can do to those queues. There are other roles, but they only really apply to the MQ console on the administrative REST API. So I've got a question here from I. Thompson, maybe Ian Thompson, who knows, saying, can you use a federated repository on ZOS, i.e. using SAF and LDAP together? So yes, I think you can. Really, the support for registries is part of the web server, so that's a separate thing from what you typically get with MQ, and that does support registry federation. It's not something we've spent a long time using, but it absolutely works with WebSphere and therefore is supported with the REST API. So you've got, there's quite a lot of combinations of things you can do here, and Liberty also provides support for OAuth and all of those other good things as well. So there's lots of stuff you can do which makes sense from a REST API. So yes, you can federate your repositories together. So this is security in terms of who's got access to what, and then of course there's how do you authenticate with the REST API in the first place. Now we've got a number of built-in capabilities which we kind of provided samples for, and we'll briefly talk about those here. So the simplest one is basically basic authentication, where when you connect into the REST API, you basically, as part of that individual HTTP request, you provide a header which provides an encrypted form or a harder to read form of your user ID and password, and you send that up via your request, and it's protected via HTTPS, so it is secure on the wire. And then the web server will take that user ID and password and pass it on to the backend registry for authentication against RACF or or LDAP or whatever. An alternative approach is to provide a client certificate. And again, that comes up with every individual request. And that certificate, again, eventually gets mapped to the back-end registry. And then we also have another one, which is a specific messaging REST or a specific MQ REST API call that basically logs you in to the REST API, and then you can interact with it multiple times with that logged in user ID and a logged in authentication token. And then there's more advanced use cases with things like OAuth and all the rest of it as well. So, you know, there's a wide variety of authentication and security support with the REST API. It's kind of too detailed to go in here, but, you know, it's all doable. So the next couple of slides, well, one more slide I wanted to cover on the REST API, and then I'm going to switch over to ZOS Connect. And I've got 15 minutes left, so I'm just going to make sure I keep to my time. 15 minutes is doable. And I wanted to talk about performance. So this comes up quite a lot. It's been a bit of an evolving story. And I think what I'll say is, you know, we've made the REST API better performing over time. So when we first did it, and the numbers here on that chart are basically example ZOS numbers, okay? So they're illustrative of what you could get for our particular environment. The general pattern applies on distributed, but these are these specific numbers. So here, when we originally did the REST API, it didn't have any connection pooling. So every individual HTTP request was a separate connection to MQ, and then, you know, put to a queue, and then you disconnected. And that's because we're trying to get this functionality out relatively quick. So that gives you a certain performance point, 180 request replies per second in our environment. And, you know, that's okay for some use cases, but it's not exactly a high throughput REST API. So subsequently, we did connection pooling, and that was done in 9.1.2. And you can see that close to doubled the throughput from our sample number. So that got you to 320 request replies per second. But there's actually another part that's quite expensive when it comes to using REST APIs, and that is TLS. Because if you don't do anything special, every single HTTP request is a separate TLS handshake to the web server, and those TLS handshakes, you know, cost basically, and so that's quite a considerable overhead when using REST APIs in general, not just for MQ, just in general. But it is actually possible to do something called an abbreviated handshake, where if you're going to issue multiple REST APIs to the same backend, the first one results in a full TLS handshake, and then subsequent ones basically make use of the results of that earlier TLS handshake. And that, if you do that, and that's something you switch on in your programming language, in your programming environment, rather than being an MQ thing, that kind of also speeds things up. And if you provide both of those capabilities together, then at 9.1.2, when you're reusing your TLS handshake, using the abbreviated handshake, and you're using connection pooling, that gets you up to about 700 request replies to the messaging REST API per second. So, you know, close to, well, actually over tripling the throughput of the REST API. So it's definitely possible to go a lot further, and you know, as well as making it faster, it also makes it cheaper. So in our environment, we saw it reduced costs by about a factor of 25. So it's, you know, quite significant. It is worth mentioning that, you know, this is nowhere near as fast as a traditional MQI or JMS application connecting in as a client. They can do about 15,000 request replies per second. So not scalable, but perhaps easier to use and accessible by more callers. So just, you know, you're trading these things off. So that's all I wanted to cover on the MQ REST API. Now I want to spend the remaining 12 minutes talking about ZOS Connect Enterprise Edition and MQ. So I'm going to give you an MQ view of ZOS Connect Enterprise. I should mention that there are at least one other, I think there's a couple of other sessions on ZOS Connect during the conference. So if you want to know more general information about ZOS Connect, I'd recommend looking at those. This is just a view of what it means from an MQ perspective. So what is ZOS Connect? So until recently, if you wanted to actually, well, let me start back a little bit. REST APIs are valuable to customers because you can run them from anywhere, right? You can run them from the cloud, you can run them from your phone, you can drive them from anywhere. And often what you want to do is you want to, existing things like CICS, IMS transactions, which expose a really valuable business capability. You want to expose those to as many possible users as you can, because you've already got the APIs. What you want to do is monetize and expose them to as wide a set of people as possible. Now, traditionally, of course, Kix transactions aren't something you can just go and drive via a REST API. The same sort of thing applies for IMS. And that's resulted in each individual piece of ZOS middleware over years building up their own set of support for REST APIs. Okay, so Kix, you had things like Kix JSON Web Services, IMS, Mobile Feature Pack, DB2, JSON. On ZOS, we've got App Connect Enterprise or the REST API. Okay, so you've got individual middleware specific solutions to exposing REST APIs. However, wouldn't it make sense in many cases actually just have a single solution that can expose all of those pieces of middleware using the same style of approach and using the same sort of administrative tooling to do so, and actually just rather than having lots of different answers to how you do REST on the mainframe, have a single answer. And that's really what the ZOS Connect Enterprise Edition product does. It gives you a standard way of exposing your existing middleware via purpose-built, beautiful, and delightful, as we like to call them, REST APIs. And that applies whether you're talking about Kix, IMS, DB2, or MQ. And that's really what ZOS Connect does. So what ZOS Connect is it's a separate product, it's a chargeable product. You buy it and you install it on your mainframe. And inside the product, there's a few bits. There's the actual runtime that provides ZOS Connect and its REST APIs, and that's based on Liberty, and it's got a whole load of extension points that ZOS Connect provides. The things that then interact with the backend middleware are these things called MQ service providers. And there's a service provider for each individual backend middleware. So there's a service provider for Kix, service provider for MQ, etc., etc. And they provide the translation between the ZOS Connect world and the backend, backend Kix transactions or backend MQ queues and things like that. And then there's a whole load of common capabilities that ZOS Connect provides. So authorization, logging, auditing, exposing your REST APIs with Swagger, and then very importantly, data transformation as well. And really that the ZOS Connect acts as the glue between the REST APIs out the front and the clients driving those REST APIs and then the backend middleware. So as well as the actual ZOS Connect runtime, like I said, a real key requirement on ZOS Connect is to actually expose these backend services as proper REST APIs, hiding the fact they're running on the mainframe, hiding the fact you're interacting with Kix. You actually want to expose it as a proper REST API, i.e. there's a URL and a set of operations that map onto that URL, and those eventually somehow map onto the backend Kix transactions and things like that. So that part is exposed to the user via the API toolkit, which is basically an Eclipse environment that you use to build up your REST APIs and hide the fact you're interacting with the mainframe. So it builds up the REST APIs, assigns URLs to individual objects, and then each individual operation eventually gets mapped to something on the backend service. So you might have a single URL that you have a post against that URL maps to a particular Kix transaction, and a delete to that URL maps to a different Kix transaction, if you see what I mean. So it kind of acts as this glue between. And a real key challenge for ZOS Connect is, as well as exposing things as like a proper REST API via URLs and HTTP verbs, is how do you deal with data transformation? So on Kix or IMS or with MQ, chances are you're moving around data in the forms of things like COBOL or PL1 copybooks. A COBOL copybook is not something that a REST API developer understands. Okay, they would typically expect to interact with a REST API and send it JSON payload. JSON is kind of the language or the data format for REST APIs. So a big part of what ZOS Connect does is actually map between traditional language structures, COBOL PR1, and JSON payload. Okay, and so on this slide, it kind of gives you a bit more of a detail of what I was describing. So here, this support is generic, regardless of whether you're connecting to KIX or MQ or anything like that. It's just a generic part of the REST API. So here we've got a request that comes into a particular URL, and as part of that request, we want to interact with customer 12345. Now, what that maps in and what ZOS Connect does for is it maps that 12345 into a particular field on a COBOL copybook, and that request then gets sent to the backend KIX transaction or IMS transaction. That fills in the rest of the COBOL copybook, the name, the address, and the telephone, and that then by ZOS Connect gets mapped back into a JSON structure which gets sent to the caller. So from the caller's perspective, it's just doing, it's driving a REST API, it's doing what it normally does when it drives REST APIs, it interacts with the URL and it gets back JSON payload. And ZOS Connect just magically does that transformation between JSON and COBOL or other language structures. And that's really, really key. We've hidden the mainframe side of things here. It just looks like a REST API. And you build these up for each individual thing you want to expose in the back end. And it doesn't really matter whether it's a KIX thing or an IMS thing or an MQ thing, it's kind of the same. So now let's look at what that means for MQ. So the MQ service provider is the piece of glue that interacts between ZOS Connect and MQ. And it provides the ability to talk to the MQ queues, and it hides the fact from the REST API that it's actually interacting with an MQ queue at all. So the REST API caller doesn't know it's dealing with MQ. It's just using a REST API, and ZOS Connect and the MQ service provider kind of do that mapping between the two for them. And of course, those sets of queues that are being exposed via REST APIs are probably already being used via an existing MQI app. And these two things kind of work together. You don't have to do one or the other, they can just exist nicely together. So from an MQ perspective, this is just another client coming in and sending messages to a request queue and getting data back from a response queue. So I'm speeding up a little bit because I've got 4 minutes left. So I'm going to go through a little bit quicker, but I've only got a few more slides, so we're kind of doing okay. So in terms of things that ZOS Connect and MQ expose, we've kind of got 3 different ideas. We've got one, which is to basically take a pair of MQ queues, a request and reply queue, and expose those as a single request, a single REST endpoint. So this is the most common use case we see with ZOS Connect, where normally you would send a message to an MQ request queue and get a response from a backend service on the reply queue. You can put a REST API on top of that and hide the messaging just via a single synchronous REST call. We also provide support for sending a message directly to an MQ queue, and sort of firing, forgetting that message, or destructively getting a message from a queue as well. But by far the most common use case of ZOS Connect is this two-way messaging pattern. And I'm going to talk through it quite quickly here. So here's an example. I've got an application, a traditional MQ application, perhaps running on the mainframe, perhaps not, sending data in the COBOL copybook with an item ID that goes to a stock request queue. Backend application running in KIX gets that request, processes it, and gives you information about that particular stock ID in terms of description, count, and cost. And I might have multiple applications doing this request, but because this backend application is something I've had for a number of years, and I want to expose it to as many applications as possible. And sometimes you might want to expose them to things that don't understand MQ, and this is where ZOS Connect comes in, because you can use ZOS Connect to expose those pairs of queue via this thing called the two-way service that I mentioned previously, and that can be used to actually just expose those pairs of queues via a single URL. So I've now built up a ZOS Connect service that says, if you get a URL that looks like this, then map that to take that 1234, which is the item ID in the COBOL copybook, take that 123 off the URL, stick it into the COBOL copybook, put it on the backend request queue, and you can see that here with this message data 0001234. I've turned that into a COBOL copybook format. That's now being put on the request queue. My existing backend application gets that, generates a response, sticks it on the reply queue, and ZOS Connect and the MQ service provider are sitting there, and they take that response message back, which is COBOL, and you can see that on this picture here. And it takes that COBOL, converts it to a JSON structure, and then sends it back as the HTTP response body. So I've converted here from a world where I'm just doing entirely MQ messaging to a world where actually I've exposed that pair of queues as a single URL, and the application calling that URL doesn't know that it's been interacting with MQ. So I've got a couple of slides here, which I think I'm going to run out of time on, just trying to compare these two things. I think it's fair to say that, you know, both ZOS Connect and MQ are valuable. MQ scales far better than ZOS Connect. You know, a single queue manager can do millions of messages a second. ZOS Connect can get to large numbers of thousands. But actually, you know, a lot of the other things are similar. Of course, if you want to interact with ZOS Connect, that exposes REST APIs. They are ubiquitous. That means anything can call ZOS Connect. Many things can call MQ, and we've got lots of specialized APIs for that. But of course, we have the built-in messaging REST API available as well. And there's just one more point and then I'll stop, which is that if we look at the messaging REST API for MQ compared to the ZOS Connect MQ support, the messaging API for MQ is a messaging API, okay? It is obvious you're dealing with MQ. You need to understand that you're dealing with MQ. You need to understand which queues you're dealing with. ZOS Connect hides that from the core. It just exposes a REST API and it's not apparently using MQ at all. Okay, so that's kind of the main distinguishing point between them. So I'm going to stop now. I realize I'm out of time. If anyone's got any questions, I'm happy to answer them.
No, I see no more questions there. You've answered excellently the ones that have appeared.
And almost on time as well.
Yep, very
almost.
Good. Right. Thank you everyone for attending. Please do fill out the feedback form, which you can click on via BYOA or use the QR code that Matt's put up. Next MQ session is at 10:30 tomorrow.
Yeah, I should say, sorry, go on, sorry.
No, carry on. I
was going to say, if anyone's got any further questions on this, if you Google my name, Matt Lemming, IBM, you'll find my email address, or it is just lemmingma@uk.ibm.com. So if you've got any questions on this stuff, feel free to ask them, and I'll get back to you straight away.